Hey everyone, in this video I'm going to show you the SAM 3.1 and I'm going to show you inside of ComfyUI we have a native support, which means you don't need any custom nodes in order to use it. And I'm going to talk about all of these nodes. This model is by Meta and it's to do masking by segment. And you can see the different examples that we have on the page. By the way, all the links will be in the description below. And if you go down, it tells you the progress between the different versions. So the SAM3, which is what we'll be using today, can do segment and object. We can do inside of a video. So we can do image, we can do for video, we can refine it. We can also detect and segment matching instances from text, and we can refine the detection using visual examples. So we go down here, there are a couple more. So we can have SAM3D. I will not be talking about the 3D version. I will only talk about the image and video version today. Now on GitHub, we have the page, and in here we have a little bit more detail on how it works. You can go ahead and read about this. What is important is that we will be using the SAM 3.1, and you can find the link to the model on Hugging Face page. And there are a few notebooks to try it out online directly. Now for ComfyUI, we'll go into Hugging Face page here. So it's going to be comfy.org SAM 3.1. This is the link. I will have it in the description below. Click on files and versions. It will take you here. Click on checkpoints, and then you will need to download this model. You can click on this download button here. You can see the size is 1.75 gigabyte. It's not huge, so you should have no issue integrating this model into your workflow. Once downloaded, you will need to place it inside of ComfyUI models checkpoints. This is a little bit unusual for a segmentation model, so just know that it goes inside the checkpoints folder. Now, as for my specs, I'm running an RTX 4070 Ti. I have 12 gigabyte of VRAM and I'm pairing it with 32 gigabyte of RAM. The top part here is my ComfyUI setup. I'm using the latest ComfyUI version. This is today's date, and my ComfyUI manager is also up to date. Once you have the SAM 3.1 FP16 downloaded and placed inside the checkpoints folder, update your ComfyUI as well as your ComfyUI manager. You don't need any other custom nodes for today's video. Now going inside of ComfyUI here, here's an example of what you can do with this model. So in here, I have an input image. This is just me on a white background. And I have a text prompt here where I'm saying ear, and you can see that it's identifying where the ear is. And you can see it from the bounding box here. Plus it's masking it out. So here's the high resolution images. This is my input image. It's identifying it here. You can see the red border. It's like a bounding box, and you can do one ear like I have here, or you can do for both, and I will show you how to do this. When you are masking it, you can be as broad as you want or as detailed as you want. So for example, here I'm saying man, and you can see it masks everything. When I say glasses, it's only the glasses here. If I say suit, and let's say you have a 2-piece or 3-piece, it will only mask the suit. So if I say tie here, it's only the tie that is getting masked. And similarly, if I say shirt, it's only the shirt inside that is getting masked. You can see here, it's also getting this part here. Now, you can also go for individual facial features. In this case, I'm saying neck, but you can see it here. I've shown you how to do ear. This one is hair, and it's able to mask everything well. Now, this model can also do multiple objects at the same time or multiple person. So in this example here, I'm saying man, and you can see I have a woman and a man. It's able to identify the man, and it's able to mask it out correctly. Here's the high resolution version. You can see the mask is really well done. We have a small opening here, and it was able to catch this opening here. So you can see in the mask, it's not selected. Now we can do the same thing for woman. So in this case, it's identifying the woman and it's doing the masking, removing the woman from the image. Now in order to identify 2 or more objects or people, we'll be using this syntax where we have human, colon, and then the number of maximum object or person that you want to select. This number is the maximum that you can have in the image. So in this case, I have 2. Which is why I've selected 2, and you can see it's identifying both of them, masking out and removing them. Now, like I said, this is the maximum number. So even though I say human colon 100 here, it's still going to identify only 2. If you have only 1, there's no need to put colon 1. In fact, if you put column 1, it's not going to work. So only if you have 2 or more, then you would use this syntax. All right, so now I'm going to go through these nodes and explain how they work. Of course, the workflow here will be available in the description below. workflow. So we'll start from the left side here. I'm going to start from the top. This is the load checkpoint. And from here, you will need to select the SAM 3.1 FP16, the same one that you've downloaded from Hugging Face page. At the bottom here is the load image. This is where you will select your input image. And I'm just going to make some space here. It goes into this SAM Detect. And this is the one that is doing the detection based on what you'll need. So you can see here we have model image conditioning, and the conditioning is what we are giving it in order to identify the object. So in this case, I'm saying microscope. Don't worry about this syntax here. I'm going to explain it. You will put your objects or person or anything that you want in here. Model image conditioning is self-explanatory. I don't have to worry about all of these. It outputs mask and bbox. The bounding box is also not necessary for a normal workflow. Instead, you will only be using the mask. That's what you will input into your workflow. But to understand how it works, I have the bbox as well, so the bounding box. And in order to see all of that, we'll be needing these additional nodes. Okay, so normal workflow, when you're trying to integrate this into some kind of masking workflow, you will need your load checkpoint, a load image, a prompt, and then the SAM3 Detect. And then you have your mask, and you can do anything you want to with it. So if you want to visualize it, you'll just need to go like this with some preview node or maybe some save nodes like I have. So let's run it, and then I'm going to explain what this does. So first, let's do microscope. This is a single object. So you can see here we have a microscope, and it's able to identify the microscope, and you can see it's doing the masking and removing it from the original image here. Now, in this case, I don't have two microscopes, but if I had multiple microscopes, I would put a colon and put a number next to it. This number will be the maximum number of objects to detect for this one. So let's say, for example, I want to remove the microscope and the chairs here. The proposed syntax for it, since we have two objects, well, actually three, two chairs plus one microscope, I will need to put a comma, space, and then chairs. And since I have two, I'm going to put colon 2 here. When I do this, you will see here it's able to identify the microscope, the chair. We have two of these, and it's masking it out, removing it from the image. So similarly, if you want to remove, let's say, the monitor as well, you can put a comma, space, monitor, and you can see we have a fourth square here, and the mask shows it properly here. It's able to remove it. If you find that you're not able to get a good mask, then you will be playing with the threshold and refine iteration. So these numbers can go up, down. By default, I think it's at 0.5 and 3. I've changed these a little bit. In case you're not getting good mask, it's too jagged or it's going inside of the object, then you can refine the iteration and the threshold as well. Now we'll take a look at a difficult example. So in this case, I have two people on a white background. Now, to make matter worse, they are wearing white clothes, and even the woman nails are white here. So in this side here, we cannot even identify where the shoulder is ending and where the white background is, just white everywhere. So when we do this, and I'm using the default, okay, so default is actually refine iteration 2 and threshold is 0.5. You can see it's able to identify both people. By the way, the prompt was human, but you can see that we have these lines in here, and it's not able to get the hands correctly as well as the shoulder. So that was kind of a difficult one. Now we can try to refine it. So refine iteration is 5, and tries to do its best, as you can see, going from this to this here. We do refine iteration 3, it's already like this. If we decrease the threshold, now you can see it's missing a little bit more of the person. So increasing the threshold is like this, and if you go to 1, it doesn't select anything. So just note that if you go to threshold 0 or threshold 1, you don't get any. So in these specific cases where there's no clear contrast between the subject and the background, it's not going to automatically recreate part of the missing object. Okay, so you will still have to do a little bit of work there. Now, in terms of application of these, I have an input image here. You can mask out the face or the eyes, and then you can do like something like this where we are adding sunglasses. You can swap the color of the clothes. You can also target a specific cloth or part of the cloth. So if you have a two-piece, or like I showed you earlier where we have multiple parts, you can target a specific part of it and just modify it. In this case, I'm just modifying the top part where I'm adding a shirt. Now you can also invert the mask. So instead of saying select the background, it's easier to select the person and then invert the mask. This way you can change the background. Now you can also use this for upscaling. So these images are the same size, but all I've done is select the face and then pass the space to a different model. So you can see this one has like a smooth output, like a smooth render, compared to these ones which has well, less smooth render. So you can see these two are different models that I'm using. So that's something else that you can do. You basically upscale just part of it, render that part, and then downscale it and place it back. Now for the second part, we are going to focus on this here, which is the video section. Now for the video, you will do the exact same thing. Instead of a SAM Detect, we'll be using the SAM Video Track, and the rest should be quite self-explanatory. Now, in order to load your video, we'll be using a load video node. And since this output a video, and since the SAM3 video track requires images, we'll pass it through this get video component, which breaks the video into its components. So we have images, audio, and FPS. We only need the images and audio. Audio only if you want to reconstruct the final video, like to have audio in the final video. You may want to use the FPF as well if you want to get the same input FPS. Now in the SAM video track, you'll only need images. Model is the same. We are still using the same SAM 3.1 model. And then you need one of these two. Conditioning is the same that we were doing here, basically using text to detect what we want, or you can use an initial mask, and this initial mask will come from the SAM3 Detect itself. So as you can see, this output mask, and you can pass this mask over as initial mask. Now this also has a detection threshold, so you can play around with it. There's the max objects here and the detect into. Now in this specific video here, I have a bird that's out of frame initially. So at the start, it's not here, and then comes into frame and then goes out of frame. So I'm using the conditioning here. So simple text, I'm saying bird. And since we have only one, I don't have the semicolon and in number next to it. Now this SAM3 video track outputs track data. And if you want to see it, there is a node for it. We have the SAM3 track preview, and it will show you that this bird is being tagged. You can see the object ID next to it. If you have multiple objects, just look at the ID. So we can see that it's 0 at the top. If we had multiple birds, it would be like 1, 2, 3, and so on. Then to select the different objects, you will go here into the track to mask, and this one takes the track data, which we are getting from here, object indices. So in here I have 0 because I have only one. You can also have comma, and then let's say there were 5 birds, but you only want the first and last one, so you will do 0 and 4. Since these are indices, the index start with 0. So object 1 is 0, object 2 is 1, and so on. Okay, so you can do your selection like this. By the way, you can also leave it empty to select everything. And once you've converted it, it goes preview image. You don't really need this preview image. This is basically the mask. You can see it here. We'll need to increase it, and let me select it. So at the beginning, we don't have anything, but after a while, once the bird comes into frame, so you can see around here is where the bird comes frame, and then it's masking it as I'm going. So I believe around here is where the bird disappears, so it goes out of frame again. Okay, so here the bird is still here, and then it goes out. Now this is just a preview. You don't really need the preview. If you don't want to see what's happening, you can remove this. And since we have images here, and obviously our input media was a video, I'm just doing a create video here, which outputs a video, and then I'm saving that video right here. So it's just a mask part that I'm getting. So you can see here we have the bird goes out of frame around here. Now, like I said, you can also use this initial mask to get the SAM Detect in here. And of course, make sure to connect all of these there. And if you are doing the SAM Detect, your conditioning, so your prompt does not go into the SAM track, it goes inside the SAM Detect. Basically, this one will do the detection, and then we pass this mask over as initial mask like this. Now you can see here I have it running, and it's actually very slow because it has to do every single frame that in the video. So if you have a video where the first 5 seconds the subject is not even present in the video, then just cut that video so that you start where the subject starts, and this way it's actually shorter. You don't waste so much resources, so much time just doing frames that are not even required. So in this case, I would basically start the video when the bird appears in the frame here, and then I would end the video the moment the bird exits. And then in a video editing application, we can concatenate it and bring the beginning and the ending back in. Now, in terms of speed, the images, it's not that much. So you can see here the images, like we are loading SAM model. It's like 1 or 2 seconds, depending on the image size. But the video one, depending on how many frames. So in this one, we had 240 frames and it took more than a minute. All right, so that is it for today. Hopefully now you know how to do masking using the SAM 3.1 model. I will leave all the links in the description below. I will recommend that you go through these 2 links. Thanks for watching until the very end. Have a nice day. Take care. I will see you next time.